And I'll write conclusion. All right, we reject the null hypothesis with p less than 0.001. Okay, does that show up? Yes, it does. We reject the null hypothesis with a p-value less than 0.001. It's a very technical statement, isn't it? So I'm going to expect you to write in plain English so that I know that you know what you're talking about. That goes along with this course. So here's my plain English interpretation. We are more than 99.9% confident that the mean number of days lost for the company is more than 5.1. All right. We are more than 99.9% confident that the mean number of days lost for the company is more than 5.1. Where'd that come from? Well, if you take 1 minus the p-value, you get 0.999. 0.999, which is 99.9%, isn't it? So that's our confidence level. Our confidence level in rejecting the null hypothesis in favor of the alternative hypothesis is more than 99.9%. And so we did accept the null hypothesis. We accepted the alternative. We rejected the null hypothesis, we accepted the alternative. And so it's like saying, okay, guilty verdict. We rejected innocence and showed guilt. All right, so there we go. That's kind of tying all that statistics stuff to the legal system. Well, I want to talk about a little bit of terminology here before we look at some additional problems. So let me erase the board and we'll come back with that. I put the hypothesis test from the last problem up on the board. Again, the null hypothesis is that mu is equal to 5.1. Alternative was mu is greater than 5.1. So we didn't prove that the mean number of days was 7.0 for that company. We just proved that there's enough evidence to show that in this company, the amount of days they miss is significantly greater than 5.1, the national average. Significantly greater in this context means statistically significant. So we'll talk a little more about that later. I want to go to top of page 270, please, where they introduce a little piece of terminology. It says the type 1 error, or alpha error in hypothesis testing is rejection of a null hypothesis that is true. And he goes on to talk about the type 2 error, beta error, in hypothesis testing is failure to reject a null hypothesis that is false. Well, we don't worry about the type 2 error in this course. Okay, the book doesn't do anything with it. So that's a little more advanced topic in statistics. Statisticians do think about type 2 error or beta error. We're going to focus on alpha, or the type 1 error. Now, you've seen Greek letter alpha used before. So alpha means the amount of type 1 error. Alright, I like to print instead of do cursive on these videos. I just have to remember to do it. Type 1 error. Well, we used alpha in confidence testing Normally we used alpha equals 0.05 because we're using 95% confidence. So for example, again, 95% confidence translated to alpha equal to 0.05, or 5% type 1 error. That was in confidence intervals, estimation. Alright, well, similar idea here, that the alpha represents the type 1 error. Now, did we see alpha in the last problem I just did? No. Yes, yes we did, but it was called the p-value. So, the p-value is the amount of type 1 error. And you're probably thinking, well, why don't they just call type 1 error the p-value? Alright, well, there's a reason for this. Alpha is used as a preset type 1 error. So it's a preset amount. Yeah, I'm not writing too good tonight. Preset amount of type 1 error. The p-value, or simply p, it's a lowercase p, by the way, lowercase p, is the calculated amount of type 1 error. Alright, so I hope all that's legible to you. Alpha is preset amount of type 1 error. P-value is the calculated amount of type 1 error. Ooh, well, what does that mean? Let's elaborate on that. The alpha in confidence intervals, we preset that. We said, okay, we're going to accept, with 95% confidence, we accept that there's a 5% chance we're going to be wrong in our estimation. Okay, we decided that beforehand. That was the standard we were going to use. In hypothesis testing, however, at least what's called modern hypothesis testing, we calculate the type 1 error. And so that's why I say the p-value is the calculated amount of type 1 error. It still may not clarify for you what is type 1 error. Let's go over that again. When I worked this problem and got a p-value which was less than 1/1000th, that says the probability that I'll make a mistake, that I'll make an error in rejecting this assumption is, by mistake, is less than 0.001. Okay, very unusual. Let's try to put that a different way. The company averaged 7.0 days. National average was 5.1. What if this company really is like the national average? People normally miss the same number of days as the national average of 5.1. What is the probability that in 1 year we're going to see 7.0 out of 49 employees? If they truly are no different than national average. Might have to digest that. That probability is very remote. It's the p-value, less than 0.001. So, but if that was true, then I would be making a mistake in rejecting this, wouldn't I? In favor of the alternative. Well, my probability of rejecting this in error is so small that it leads us to conclude that, it's a safe bet. We reject this in favor of the alternative. 99.9% confident. So,